Hi there, and thanks for tuning in. Today we're going to be looking at lesson 12.0, solving equations with variables on both sides. Today you're going to be writing down 9 things in your notes, so let's go ahead and get started. The first thing we want to make sure we understand is in order to solve equations with variables on both sides, the variable has to be on one side of the equation sign and the constant has to be on the other side of the equation sign. Maybe an example would look something like this, where you have a negative 3x over here and a 27 on the right, or 13 on the left and a positive 2x on the right. Notice that the equation sign is separating your variables and your constants, and that's the main goal that you want to get, because once you're here, then you can start to solve and get your answer. Okay, let's go ahead and take time now to pause the video here so you can write down what you see for number 1, and then click play when you're ready for number 2. Okay, so this next one you're going to work out with me on your paper, so just follow along as we go. Your reminder is to get variables on one side and then get the constants on the other side. So what we're going to be doing here is taking x's and moving it to the left and or to the right, and then the 5 and the 1 and putting it on the left or right either. What I'm going to do is I'm going to actually take my 1x, and move it over to the right, because it's easier to do 3 minus x versus x minus 3, or 3x minus x versus x minus 3x. Okay, these two x's will cross out, so go ahead and cross those out on your paper. So all we have left right here is 5 equals 3x minus x is 2x, and then plus 1. Okay, notice I still have a constant on the same side as the variable, so I do need to move that one as well. And how I move that one is also with the opposite operation. So plus 1, the opposite is minus 1. Whatever I do to one side of the equation sign, I will do to the other. These two ones cancel out, so what I have left now is 4 equals 2x. And this is exactly where we needed to be in order to solve the equation. Now that I have this, I can just perform my last and final operation, which is the opposite of multiplying, and that'll be to divide. So x is equal to 2. Okay? This next one you're going to try on your own. So I'm going to start you off easy. You only have to move one thing and then solve it. Go ahead and pause the video now to get your variables on one side, your constant on the other, and then once you solve it, click play to check your work. Okay, so by now you should have noticed or solved your problem. And you notice that the negative 2x is away from the negative 7x. So I'm going to add negative 2x to this side over here. Okay. These two x's cancel out, so all I'm left with is 15 on the left side, which is perfect. I needed that constant by itself. The thing you got to remember though here, negative 7x plus 2x. These are different signs, so you actually had to subtract these. You do need to make sure that you keep your integer rules in mind. That is from lesson 1.2 if you needed to go back to it. So negative 7x plus 2x is negative 5x. Okay, that's different sign, subtract. Keep the sign of the larger value, then you'll be exact. Remember that song? If you don't, go back to chapter 1. Then you're going to divide to finalize your answer. So I'm going to divide both sides by negative 5. Again, this is where you've got to keep your integer rules in mind. 15 divided by negative 5 will give you a negative 3 according to your rules of Monkey Man and multiplying and dividing with negatives. Again, if you can't remember Monkey Man, this is in lesson 1.5. Any thoughts or this? Go back and rewind it. If not, let's go on and go on to number 4. Number 4 is a little bit different because now you're going to have to distribute the numbers first and then move your constants and variables. I do want you to try number 4 on your own. So let's go ahead and pause it first, distribute, and then move your constants and variables, and then click play to check your work. Sorry about that interruption. Our distributed property is going to make these two things change. Negative 2 times x is a negative 2x. Okay? But when you're distributing here to the next one, it's negative 2 times a negative 5, because this negative goes with the 5. So that's actually going to give me a positive 10. Over here on the right side, I'm going to do 6 times 2, which is 12. And 6 times negative 1x, that's going to be negative 3x. Remember, multiplying 6 by a half, or anything by half, is just dividing it by 2. Now we're ready to move our variables. What I'm going to do is I'm going to take negative 3x and move it to the other side. These 3's cancel out. Negative 2 plus a positive 3 will give me a positive 1x. So I have 1x plus 10 equals 12. The next thing I'm going to do is go ahead and move my constants, so they're on the same side. I'm going to subtract 10 because that's the opposite of plus. These 10's cancel out. I have 1x is equal to 2. And notice, remember that 1x always equals x. So really, your answer x is equal to 2 is already there. If you divide it by 1, totally fine. You still get x is equal to 2 for your answer. Here's another one you're going to solve. Once you're done solving it, we're going to go over it, and then I'm also going to show you how you can check your solution. So let's go ahead and pause the video now, try number 5, and once you're done, click play to check your work. Okay, so we have negative 3x is equal to 2x plus 19. I'm going to subtract 2x from both sides. These 2x's cancel out, so I have negative 3 and negative 2 makes negative 5x. And then all that's left over here is 19. Then I'm going to divide both sides by negative 5. And x will be equal to a decimal because 5 can't go into 19 evenly. Let's see, that's going to be 3 with 4 left over. So 3.8. Okay. Since x is equal to 3.8, if I plug 3.8 back into the original problem, they should be balanced. So here's my original problem, and what I'm going to do is go ahead and work these out. 3 times 3.8 is going to give me 11.4, negative 11.4, excuse me. 2 times 3.8 is going to give me 7.6. Okay. One mistake I forgot is I did 19 divided by negative 5, so this 3.8 should be a negative 3.8. So when you're multiplying, these should end up being negative. I now have negative 11.4 is equal to negative 7.6 plus 19. That's basically saying is 19 going to be equal to negative 11.4. Also keeping in mind too, I didn't factor in multiplying my negatives here. So when I multiplied negative 3 times the negative 3.8, I get a positive 11.4. And 19 minus 7.6 does give me 11.4. So yes, my solution is correct. I just needed, a good thing I did check my solution because before I didn't realize I didn't keep the negative. And so that's always a good idea to plug in your solution back into the equation to make sure it's balanced. Go ahead and try number 6 now. This is distributive property and an easier one. Pause it, click play when you're ready to check. Okay, so first thing you did was 6 times 4. And then you also did 6 times negative z. Okay, 6 times 4 is 24. 6 times negative z is negative 6z. And that's all equal to 2z. To solve, I need to move my variables to one side. So I'm going to add 6z to both sides. So I get 24 equals 8z. And then when I divide both sides by 3, divides both sides by 8, I get 3. Again, to check your solution, just plug in 3 to the original problem. I know 4 minus 3 is 1, and 6 times 1 is 6, and then 2 times 3 is also 6. That means we got our solution correct. Here's number 7. Again, let's go ahead and pause, try it. Just having you try a bunch of these so you're getting used to them. Alright, so what I did is I moved 2y over to the right. Once you move 2y over to the right, you are going to see that these 2y's cancel out, so all you have left is 6 is equal to 2y minus 1. I'm going to plus 1 to both sides, so I get 7 is equal to 2y, and then divide both sides by 2, y is equal to 3.5. Okay. Number 8, again, moving things. Let's go ahead and pause, try it, and then click play. Alright, so what I did with this one is I moved my negative 4x to the other side where the other x is. Negative 4x plus x is 5x. So I have 3 plus 5x is equal to negative 17. And then I'm going to subtract 3 from both sides. Notice I'm doing negative 17 and negative 3. Those are same signs, so you're going to add and keep them. So you actually get negative 20 for that. Then you will divide both sides by 5. X will be equal to negative 4. That one will be a good one to check. Is 3 plus negative 4 the same thing as negative 17 minus 4 times negative 4? This is going to give us negative 16. So negative 17, and a positive 16 does give us negative 1, and 3 plus negative 4 does give us negative 1 as well. Last one, here's one for you to try. Again, let's pause it, try it. Be careful of this extra guy right here. Once you've tried it, you should have distributed first. 3 times 2x is 6x. 3 times negative 5 is negative 15. And then I have plus x is equal to negative 4x plus 7. What I would do first before you start moving stuff is combine like terms. 6x plus x is 7x. So 7x minus 15 is equal to negative 4x plus 7. Okay, I'm going to add 15 to the other side. So I have 7x equals negative 4x plus 22. And then I'm going to add 4x to both sides. 11x is equal to 22. Divide both sides by 11. X is equal to 2. Okay. Notice I started with moving the constants that time, and it really doesn't matter just as long as you move constants to one side, variables to the other. That's going to conclude our video for today. Thanks so much for tuning in, and we'll catch you next time.